Okay, so today we're going to be starting off with these. You're going over the properties of real numbers collaborative, so you guys are going to be going through those in your group. So go ahead and let me put you guys in breakout rooms for that. Group 4. Oh wait, page 1 is. I thought that was group 4. Oh, there we are. All right, great. So group 4, go ahead and explain.
Okay, so for 1A, it says our negative integers natural numbers, and we said no because natural numbers are like come naturally when we're counting, so 1, 2, 3, 4, and naturally we wouldn't really start with like negative numbers, so that's why we said no.
Yep, sounds good.
1B, it asks, can a number be both an integer and a full number? And we said yes because integers include negative numbers and whole numbers and positive numbers, and then whole numbers are just again kind of like 0, 1, 2. So we said like yes, it can be an example of what is an example of.
Perfect. Excellent. Great. Someone else? Someone else step up? Yes.
I can do C. So are natural numbers also rational numbers? So no, they're not. So natural numbers are not rational numbers, and it's because natural numbers are whole numbers, and rational numbers are just like fractions.
Oh, well, that's interesting. So, for example, right, so that I could see the confusion there. So rational is just a number expressed as one number over another number. So if I had, say, the number 4, right? So number 4 is definitely a natural number. Can I express that as a fraction? Right. So I could actually, so yeah, so it's a good thought. I understand. I get your thinking. I like the fact that you guys thought about it. So that's excellent. And we'll change that one like that. No worries. Perfect. Good deal. Great. Next. Keep going. 2A.
The second one, the real numbers are all around us. Give an example of a real world situation. A whole number, like we just said when we try to count anything.
Yep.
Like 1, 2, 3, 4, something.
Perfect. Okay. Sounds good.
Then for B, give an example of a real world situation in which a negative number might be used. We said when you are taking a certain amount away.
Oh, that makes sense. Right. Sounds good. Perfect.
And for C, give an example of a real world situation in which an rational number might be used. We said when we want a certain amount in a recipe.
Okay, that can work. I always think of like, you know, when you need square roots whenever you're doing like Pythagorean theorem, things like that. But yeah, that's all good. That works. Terrific. I'm sure other people have different answers. Group 6, you're doing number 3. So thank you, group 4. Group 6. Oh, let me clear my board. Sorry, hold on. Okay, great. Group 6, go ahead. Okay, yeah, so I need you to explain it, not just read it.
Well, the negative for A, we had, it's negative 21. So, it can be in the rational form because it could be a negative 21 over 1. So basically it's the same as the negative 20.
Perfect. Because any number over 1 is just itself. Great. Excellent.
Right. And then for B, we got the 47 over 11, so you can break that mixed number down.
Okay.
Just keep breaking that one down. So we got the 47
Perfect.
over 11, so we broke it down.
How did you guys do that?
So basically, it's 4 times 11,
Uh-huh.
which is 44, plus
Nice.
50, which is 47.
Perfect. Excellent. Good job. So C, I have a little bit of a problem with C. So here's the thing about C. If I do -3, you're telling me that -3 times itself will give me this.
We was going the square root of the -9, which was the 3.
Okay. So I would agree that negative square root of 9 is -3. My problem is this isn't rational. Rational has to be a number over another number.
Oh, yeah.
So what do you guys think you want to do with that? Can you fix it?
Oh, because it's an irrational number?
I just want you to write it in rational form. So rational is one number is as a fraction form. It's not a fraction.
Oh.
So how would you make that into a fraction?
So the -3 over,
Mm-hmm. Over what? I'm sorry, I didn't hear you.
I think it's the -3 over 1.
Yep. Sounds good. Great. And then this one, yeah, this one is an irrational number, so you can't put it. It's a square root. You can't do that.
Yeah.
Okay. Sounds good. So number 4, problem 4 is group 7. Go ahead and there's more than this, aren't there? Is that the only natural number? Oh, maybe it is the only natural number.
Yeah, let's check.
Oh, this guy. So some of them, if you simplify them, can be considered are natural numbers. There's one more. Which one have you?
16.
Uh-huh.
4.
Yeah. Good.
All right, and then for whole numbers, we put 0 and 2. And would we also put square root of 16 as well?
You betcha. Nice. Great. All right. Good. Negative integers.
The negative integers is -4, I think.
Yeah.
Number less than 0.
Yeah, but there's also another one now. Now that, and then when you simplify them, like same as you simplify 16, it's 4. No, this is negative 3.55555. So that's not it. But there's another negative number.
I think she's talking about negative square root of 25.
Yep. Because square root of 25 is really 5, so this is negative square root of 25.
So you call that the square root. Oh, sorry, I didn't know the word.
Yeah, no worries. It's all good.
And then for number B, I think you have -4, 0, and 2. So these are the whole numbers that can be positive or negative.
Yeah, now here's the thing. You got to add some, right, now?
Yeah, now we do the square root of 25 as well, and then the square root of 16.
Uh-huh. Yep. Good. Perfect.
Right. I got the last two using at that, and there's a lot we wrote down here. So,
Mm-hmm. Yes.
probably negative 3.5.
Uh-huh.
2.5 is the actual power. I don't know what to call it.
Uh-huh.
2/3, -1/3, absolute value of -2.8.
Yep.
Square root of 16 and the negative square root of 35, and the rationale methods are perfect squares.
Perfect. So that means that this guy should go up there as well then. The -25.
Yeah.
Right. So I'll pop him up there too. Because he's the same thing as -5. Good. So we'll erase them up here. And then the irrationals, you've got a couple?
Yeah, you got square root of 3 and pi.
Pi. Perfect. Great. Thank you. So let's see. We've got next we have page 4, so that's group 7. Oh, this is page 4, group 7. So next we have page 5, which is group 1. So group 1, go ahead. Group 1, that's Carly, Daniel, Michael, Sean.
Okay, I'm here now. Out of myself for you. I'm speaking halfway through.
No worries.
So you see addition defines the additive and multiplicative inverse. So to find the additive inverse of -2.5, you add 2.5. So you zero out.
Okay, so yeah, because when you, why is it again? Because why is 2.5 the additive inverse of -2.5?
Because you turn the number from a negative to a positive.
Okay, sounds good.
That's what I did.
Okay, go ahead. Great, next. So you guys remember the additive inverse, the idea of it is what number can you add to -2.5 to get 0? So if you're saying if you take the kind of the opposite sign of it, then when you add them you get 0. Perfect. Next person. Carly, Daniel, Michael.
Here, I'll take these.
Okay.
So multiplicative inverse of 4. So naturally thinking multiplication, you have to turn to a fraction. It's naturally going to be 4/1. So for multiplication, you do the inverse. So then it becomes 4/1 times 1/4, which is 4/4, which simplifies to 1. You can't have 0 at the end of the phone.
Perfect.
That sort of does the last one too.
Excellent. Good, yep, because what can you multiply by 0 to get 1? There's nothing. No matter what you multiply by 0, you're going to get 0. So you can't multiply, there's nothing you can multiply by 0 to get 1. Terrific. Yeah, please.
So the last one is on A, the answer would become 0 on that one?
No, because, okay, so here's 0 times, well, you'd say, I'm going to multiply it by its reciprocal, right? So its reciprocal would be, if you made this 0/1, you multiply it by 1/0, but any number divided by 0 is undefined, right? So that's undefined. Oh, yes. No, yeah, if you add them, because it's additive. Well, okay, so here's the thing. Oh, yes, so if it was, what's the additive inverse of 0? Is 0, yes. Is that your question?
Well, the first one would become 0 and it's fine, but the second one, the answer is 1, right?
Yes. Right. Yes. Okay, so thanks for pointing that out. So here's the thing. Let me get back to, let me stop sharing for a second. So here's the thing. They center around certain things. Multiplication starts off with 1. It centers around 1. Why? Because any number multiplied by what is itself? By 1. any number multiplied by 1 is itself. So that's why the multiplicative inverse centers around 1. So if you're, so multiplicative inverse is what multiplied, a number multiplied by what gives you 1. And the answer is any number multiplied by its reciprocal. Reciprocal is when you take the numerator and the denominator and you flip them. So like 2/3 become 3/2, right? 4 is really 4 over 1, so it becomes 1/4, like we just found out. Additive inverses, additive addition centers around 0. Why? Because if you add 0 to any number, you still get itself. So additive inverses focuses around 0 because that's how you get itself, by adding 0 to it. So additive inverses are what can you add to it to get 0. Does that make sense? So always, yeah, great question. I'm glad you asked that. So yeah, additive inverses center around 0 because that is what you can add to something to get itself. And multiplicative multiplication centers around 1. You always start with 1. So addition, you always have an invisible 0 you're starting with, and multiplication, you always have an invisible 1 you're starting with, which is going to come up a little bit later when we talk about powers. So good questions. Thank you for asking that. Yeah, excellent. Share screen. So next we have group 2 on number 6. So group 2, go ahead.
Yeah, for the first one, A, we got no, because the multiplicative inverse must equal 1.
Yep, perfect. And you multiply those, you do not get 1. You get like negative 4/9. Great.
Yeah.
For B, I put yes, because it's additive, they equal 0, and the additive inverse of any other number will be negative of that same number, and additive inverse of any negative number will be positive, vice versa.
Perfect. Nicely said. Terrific.
For C, we got no because the solution to this problem would be like negative 9/4, which is just not equal to 1.
Right. When you multiply them, you do not get 1. You actually end up getting negative. They're inverses, but they're negative. So you end up getting negative 1 or something like that. But yes, you're right. They don't equal 1. Terrific. Well done. Let me screen save that one. And then next we have, that was group 2, so group 3 for number 7. Go ahead.
The first one, we put that was an example of distributive property,
Mm-hmm.
which you can multiply each sum by
Right.
each add-in.
Yep.
So you just distribute
3.
to the parentheses, you can end up with 3x plus 6 equals 0.
Perfect. Right. You're doing this times that.
Second one, you said it was an example of the multiplicative inverse,
Uh-huh.
which is the inverse or reciprocal of a number. So, for example, A B reciprocal would be B over A.
Perfect. Nice.
And for the third one, we said it was the commutative property, which is changing the order of the operation so that it changes the result.
Excellent.
Okay. So for 5 over 0, we actually got H for undefined because 0 doesn't have any value. And then for 0 plus 7 is actually additive identity because it doesn't, because the 0 is in there, so whichever 0 you get it back is no number.
Mm-hmm.
So that was that would be. And then the last one is actually associative because associative property doesn't matter where the groups are paired in the parentheses, you still get the same result. So that would be associative property, which is B.
Great.
For the next one, got multiplicative identity because it's just A times 1 equals A.
Mm-hmm.
We got associative property because no matter what order you put them in, it's the same.
Right. Yep.
And the last one was additive inverse.
Mm-hmm.
Was that number plus a negative equals 0 or vice versa. So negative 5 plus 5 equals 0.
Sounds good. Yeah, multiplying it by adding it to its inverse gives you 0. Perfect. Nice. Great. And then last we have group 5 doing the last problem.
So for problem number 8A, I take the 4 and I distribute it, and I get 4W, and 4 times negative 12 is negative 48, so 4W minus 48.
Great.
For 8B, I distribute the negative 3. That so I get negative 3A, negative 3 times negative 2B becomes positive, so I get plus 50, and negative 3 times 7 is negative 20.
Great.
And for 8B, I distribute the negative 8x, and that times the x becomes negative 8 squared. And then I distribute the negative 8x times negative 3, and that becomes positive 24x.
Right. So don't forget, guys, a negative times a negative gives you a positive. Okay. Good.
For number 9, said commutative properties of addition and multiplication show that in some cases the order of the number still has the same answer. So basically, no matter how you rearrange the equation as far as the parentheses, the answer should always come out like X.
Right, no matter what order they're in. Wait, you're doing 9, right, or 10? Are you doing 9?
I was reading off 9.
Okay, yep. Yep, exactly. Perfect. No matter what order it is, and perfect. Excellent. And then for number 10,
and the answer would still be obtained, kind of like what he was saying, but with parentheses, basically.
terrific. Good. All right, good job, everybody. So let's go ahead and hop back. So you guys should have all those done, those sheets done. So the rest of the things we're doing today, we're going to finish up our syllabus quiz, which we never got to. I've been meaning to do that since the first day. And then we have our accuracy, precision, and estimation. We're going to go through partly together the first couple pages, and then you guys are going to finish up the other 3 in new groups, different groups. And then I would like to get to negative exponents and scientific notation today if possible. And then I want to go over for sure your inequalities and intervals and graphs homework, which is due next Friday. So these are the things that are due coming up. Monday you have your first My Math Lab homework due, Unit 1, real numbers, so get on that. Your homework is worth a lot more in this class, so we take the pressure off the exams. So exams are only worth 40% of your grade, and your homework is worth like 30% of your grade. 30 or 35, it's worth a lot. So, make sure you take care and get these homeworks done. That's important. Because that's kind of proving that you know it, and it's also helping you learn it. And here's the thing. Let me show you my math lab. So I just type it in the top. It comes up in the Google search. And then you sign in. Okay. You know what, I will sign in. I'll show you guys afterwards. I don't want to take time right now signing in. I'll do that in a second. After while you guys are doing all this, I'll get it ready. And then also that growth mindset. So the very first, I think, like 6 pages of your handout is the growth mindset stuff. It's
on my math lab it says chapter or unit 1 is due.
Oh, it's a little bit earlier. I think you're right. It's due on Wednesday. My bad. So it might be Wednesday. Okay. So I might have bumped these back a little bit. You might have a little more room off of that. Sorry about that. So a little bit of breathing room. So I'll move this. You're saying this goes here instead?
Yeah.
Okay, that could very well be. So then this would be Friday. And then this you won't have yet. Oops. All right, that seems reasonable. Okay, so it's probably more like this. So Monday, again, you guys still have a little bit of a break. You have to turn in notes pages 20 and 26. You have to upload those, right? That's proof of attendance. So today I expect you guys to complete pages 20 and 26 from your handout and also read these growth mindset questions. So the growth mindset questions is this part right here. And actually read it. I know you guys have read a lot of growth mindset, but they're all a little bit different. Read it anyways, and then fill out these questions here. I will know if you read it depending on, you should be, in these questions, you should relate to stuff in the article. Right? Prove to me you've actually read the article. And then pages 20 and 26 are this one, which you're going to be doing in a little bit. And 26 is this one here from the scientific notation that we should be getting to. So those are the two to upload to prove that you attended today. So let's go ahead and start in on a syllabus quiz. Let me grab that up. Here it is. Copy the link. I'm going to paste the link into the chat, and I'm going to put you guys into new chat rooms. So go ahead and everyone click on that link right now in the chat. And in your breakout rooms, I want you guys to introduce yourselves and tell your neighbors 2 interesting facts about yourself. So introduce yourself and give 2 interesting facts about yourself in the groups, and you'll be in brand new groups. Keep note of your room because you'll need it for later. So hop in and then work on this syllabus quiz together. You can rely on the syllabus to talk about it, everything else. Wait, who's leaving early? Someone has to leave early. Pablo? Oh, it's an extra one.